Hello everyone, in today's lesson we will be diving into another existing Python Pandas data analysis project by leveraging or additional Python libraries. Our dataset will focus on the dynamic field of data science. We will cover the entire process from manipulating and grouping the data to in-depth analysis, and visualization. So stay tuned until the end, as we will be creating a couple of informative charts and even dynamic ones when you are just clicking up, it just being exchanged. And we will cover the entire process from manipulating, grouping the data, and visualize it. So stay tuned and don't forget to subscribe to my channel to catch up similar content in the future. Also explore our other videos for more insights and a deeper understanding of the data science real. Thank you for joining us, and let's embark on this data exploration. Okay, let's start our project, and this is the Python interface. I have already explained how to install it and run it. You should know it. So we will create a new file and call it COVID-19. So we will call it COVID-19 here, COVID-19, and then we will import all the necessary libraries. Import pandas spd. I have already installed all of them, and this is very easy. You will just type in pip install and the name of the library, and then you will just import the second library called import matplotlib pyplot splt, and then we will import the seaborn, and then we will import what? Plotly express. Import plotly express spx. Okay, click shift enter. Plotly express, and it will import all these libraries here. Okay, first we will just need to import the dataset by typing the df equals to pd read csv. The dataset is located inside of the data folder here. The name of the file will be this one. I will put this file in the description below, so from where you can just use it. So the name of the folder will be data, and the file name will be this one. So we will just import the first 5 rows here, 5 rows, and it will import the dataset here. You could see we have lots of columns here. First we will check just a little bit information about our project by typing the df is null if there are, for example, some null values inside of it. By just typing the if is null sum, you could see there are no null values. We are lucky, we don't need to remove anything. Again, we will just type in the df shape to get out get a little bit information about the rows and columns. You could see it has 187 rows and 15 columns, and the column names, the list of the column names, in case that not all of them are printed. Okay, and this is the column names. Okay, first we will just try to analyze the region analysis. We will just try to aggregate based on the region. This you could see the last column is said double age origin. Okay, it has some regions here, so we will aggregate based on this column. We will just copy it here, copy it, and group it by that region. Okay, so I will just type in the df first, df group by. The name of the column will be this one, WH region, and we will need the numeric data. What will be picked? This one, confirmed cases, will be the first column that we are going to aggregate. Okay, confirmed cases. If I just run this cell, nothing will be happened, but if I add the aggregation function called sum, it will just sum up all these values for each specific region. Okay, and what we are going to do right now, we could add in the sort values here by typing the sort values, and just sort it as in a descending order. Ascending equals to false. Okay, run it, and you could see that it will just sort it out and filter, and Americas will take this first place. And interestingly, if you are just going to plot it, it's very easy in Pandas. You will just type in the plot and kind equals to bar, and that's a lot. This will just plot it your dataset. You could see Americas has taken the first place. We will customize it for a little bit. If you want, we will just add in the PLT title. Title equals to what? Total confirmed cases. Total confirmed cases by like region, by region, and then we will add in the PLT X label. X label will be region, and Y label will be total confirmed cases. Like copy it, PLT. Y label will be Y label total confirmed cases. Total confirmed cases. And you could see this just has added titles and these Y sticks, and we could even rotate them by adding the PLT X ticks, and rotation will be equals to 45. Okay, you could see that it will rotate them up, and these numbers are just automatically are being generated by the pandas, so that because the values are too big, and when they are just summed up, it will just give us the length and round it up to the specific thousands or millions. Does not matter. Okay, don't worry about it. We will not work on them right now. So it's just showing the statistic about the regions and print it out. So we need to make it a little bigger. We are just adding the PLT figure here. PLT figure. We will add it at the top because the bottom will not work. So fixed size equals to what? Equals to like 10 and 6. Okay, I will just make it a bit bigger. I will get rid of all these strings by adding the plt.show. Okay, and click shift enter, and again we could add in the plt grid if you want. Only the plt grid here, vertical horizontal lines. Like if I just type in plt grid, line axis will be equals to y. It should add in the grid, and it looks better right now. Okay, and this is the first chart that we have showed to you. The second step is printing out the active cases again. This is the active column, like this one. We will just group it again, but not based on the region, but based on the country. So we will pick out all this like code here and try to customize it. Instead of double H region, we will just add in what? Country, because we are just picking the country column which is existing here, like this one, a country region column. Okay, sorry, I will just add in the country region column here, and instead of the confirmed, I will add in this column. This was confirmed, I will just add in this active numeric column. Okay, this will be active, and some will still some sort values will be in a descending order. Okay, and we will just, if I just print it out right now, it will show up lots of values here because there are lots of countries here. Okay, but I need the first 10 countries. So we have already sorted it in a descending order, and we are adding what? Head 10 to print out the first 10 countries. Okay, it has printed out the first 10 countries: US, Brazil, India. You could see US has taken the first place by total confirmed cases. Okay, so we need to right now change up these titles and labels by typing the top 10 countries with like highest active cases. Okay, X label will be country, not region, country, and Y label will be number of active cases. Okay, and then grid could still stay the same, or even instead of the one grid I will add in the true, so it will print out both of them. And you could see this chart looks a bit better than this one. And in any way, we are just showing up the second chart and print out the statistic top 10 countries with high active cases. Okay, US has taken the first place here. The third step is the correlation analysis. This is more interesting. What is the correlation analysis? The correlation analysis is just like when you plot correlation based on color, you are visually representing how strongly two sets of data are related. You know, warmer colors for positive correlation, cooler colors for negative ones, or neither ones for no correlation. You know, if I just try to print out the dataset here in the F, you could see we have like these columns, these four numeric data here. So we will try to correlate them and find in the like the comparison between them. So if I just try to add in the correlation, pick them up and store to the variable correlation equals, for example, I will pick up all these four columns, confirmed, copy it, then I will add in the depth, then recovered, like recovered, and then active. Okay, if I just print out this variable here, it will extract four columns for us, right? And I will try to correlate them up here. If I just add in the core method here and print it out, it will show the comparison and the percentage sign for each specific, for example, correlated row. So if you are just visually represent it, it will be more clear for you. So I will just try to do it like that by adding or visualizing it plt. I will use imshow method and store the variable here, this correlation variable, and then I will add in another like parameter called smap and add in cool warm, for example, and then interpolate it like interpolation equals to nearest. Okay, you could see that it will create like the correlation chart for us, but it does not have any information about our data set right now. So we will just try to add in the plt cool color bar and the sticks here. You could see this is the color bar from 0 to 1, from 0.7 to 1, and then we will add in the like labels plt x sticks, because this should be understandable, sticks equal to, so we will just if I just type in the correlation again here, just run it, you could see it will print out the dataset already. Okay, if I just, it will just aggregate, group it, and some based on their values it will correlate, print it out. But if I just print out the column names here, it will print out the column names that we are going to use here. So in x sticks we will add in the range of columns based on their length, like len, these correlation columns will be picked here, because we need to know the correlation, which values are which ones. So the first one will be correlation columns, this will be for horizontal line, so I will add in it again as a second parameter and rotate it, rotation equals to 45. Okay, if I click shift enter, it will just range takes no arguments. Okay, we have like syntax error here, and we'll delete it. And you could see that it will just print out the confirmed, that's recovered, active cases for us. In the same way, we will just create the Y labels, and I will show you the comparison here. Correlation columns, no need to rotate them out. So if I just run them, you could see that this is the dependency and the comparison between the active cases, confirmed cases, and these datasets. For example, for active cases, the recovered is blue, so it is the minimum. Okay, and for recovered, the active cases this is like the intersection between them. For recovered, the active cases also is similar. For example, deaths are highest or are a bit highest for the confirmed cases. Okay, but for active it's much smaller. And for the active here, the confirmed the deaths is also the similar. You can for deaths, for example, the confirmed cases are like this color. Okay, for confirmed, the deaths cases also in the same column. This means this is a correlation. Okay, so and now we will just print out or get rid of all these values by typing plt these strings by typing the plt show. Okay, and I can even have learned another method called plt type layout, and this will be just make it a bit fitted to the interface. Okay, okay, that looks good right now. So we will, by adding, if I just added the plt figure here, I think that it will be more clear. If I add plt figure here, you will see that it will plot it in a big way. If I just remove it, it will be a bit smaller. Okay, for bar chart it's clear, but no worry. Okay, let's just try to move to another shift, like to another chart, and compare the case fatality and the recovery rate. So we will just, in order to find out the case fatality, I will just first print out the df head. Okay, you could see in order to find the case fatality, we will need to divide this to the confirmed. Okay, in order to find the fatality rate. So we will just type in the create a new column and just type in the df like fatality rate. Type in the fatality rate equals to what? df this deaths column divided by confirmed, like this confirmed column. Okay, and multiply it by 100. Multiply by 100, it will print out or create another column and show up. If I just print it out again, it will show up. You could see this one fatality rate of this based on these values like this and confirmed. This is 3.49. this is the fatality rate. Okay, and again the same way we will create another column called like recovery rate, df recovery rate, and this will be what? df recovered, like this recovered, divided by the confirmed cases. So I will just copy this recovered and I will divide it to the confirmed cases. The first one, death, is divided, and then we will divide the recovered to the confirmed again and multiply it by 100. Okay, I will just run it and it will again create another column here. You could see the recovery rate, fatality rate, two columns are being created. Now I will just plot it with the help of the Seaborn called scatterplot. Like scatter plot, scatter plot. X will be what? Like case fatality or fatality rate. X will be fatality rate. I will just try to compare them. And the another one will be Y equals to recovery rate. And the data, of course, is the DF. Data frame is here. If I just click Shift Enter, you could see that the recovery rate, there are lots of values near to the recovery rate. It means that the recovery rate is way higher than the fatality rate here. It means that the medicine has worked pretty well and recovered all the people, all the confirmed or all the ill people. Okay, and now we will just add in these labels here. Again, I will not type them from scratch. I will just copy them and add it here. So title will be case fatality versus recovery, and then X label will be fatality, Y label will be recovery. Okay, grid is also true. Sticks, no need here, like, okay, but we will need the figure, I think. Okay, yes, I will import the figure here, PLT figure, and now that method would work, I think. If I just type in the PLT figure here at the top, run it, it will run, it will just make it bigger. And if I add it here, this like method here, this will be clear here, I think. You could see that will stretch it up to the whole interface. Okay, that's the power of this method. Okay, now we will print out the new cases analysis, and new cases is also will be a bit different, but we will print it out with the help of the pie chart. Okay, so I will just pick up one of these values here, like this one. Again, I will just copy and paste it here, and I will just group it by country region, and instead of the active, I will just type in the new cases. Okay, and new cases will be here. Some, of course, sound ascending will be false, in a descending order, but plot will be pie here, not bar. I will just print it with pie chart, and if I just run it, you could see it will create the pie chart, but we will customize it for a little bit. We will just type it top 10 countries with highest new cases, top 10 with highest new cases here, new cases. X label will be again country, Y label will be the number of new cases, and we could even add in the figure is being added here. If I just try it again, you could see that it will just, yes, print it out without problem. And grid is no need here. Okay, and that looks good. And the next one will be what? The deaths versus recovered. Okay, this one is also interesting. Again, I will just PLT figure. Let's try to scatter plot it. I will just copy this one, PLT figure. I will type in the death here. X will be the death column. This should not be created from scratch. We have already have them, like the head. If I just print out this one, we have death and recover. Okay, so I will pick those columns, deaths. So we are just comparing the deaths and recovered. Okay, and here title will be deaths versus recovered. I will just copy them and paste it here. Title deaths versus recovered. X label will be deaths, Y label will be recovery. Okay, recovered. Okay, and PLT show also is better. So you could see that this is the scatter plot that has visualized the deaths against recovered. You could see the recovered is going to be increased, while the deaths not. Okay, you could see the deaths are just going to be minimum here. So, and right now we are just try to create another pie chart, but we will print out the top 10 countries with the maximum number of COVID-19 cases. Okay, we will just copy this one. I will try to customize this pie chart a little bit. PLT, we will first group the country, region, and deaths here. I will just type in the deaths. We have printed out active cases, new cases, and deaths will be printed here because we have deaths column here. You can see this one. Okay, and print out the first 10 like rows here. The first 10. If I just Ctrl X and comment it out, run it, you could see that these are the top 10 countries. Okay, and now if I just try to visualize them, I will just add in the PLT figure, pie chart, like this figure size, title, and everything. So additionally, I can even add in the PLT pie index, or after percentage sign. The first one will be, I will store it here, and by create another, if I just run it, it will just look like that. So I will create PLT pie chart, and even this PLT pie chart, this will be the variable, okay, or pie chart. Let's just make it pie chart. Okay, chart equals to what? PLT pie. We will first pick out the labels and the dataset itself. Okay, if I just type in the df like 6 here, and this PLT pie df6 will be stored here. Okay, labels will be what? Labels will be like df6. It's df6. If I just run it, first I will run it here and run it here. You could see df6 index will be the labels, okay, like this one. So I will just try to df6 index will be typed to the labels, and add in the labels equals to df6 index, and add in the after PCT. This would, instead of the values, it would add in the percentage signs, and inside of the percentage I will just round it to the 2 decimal points, 2 F, and 1 percentage sign more. Okay, if I just run it, you could see that it will just print it out in a more better way. Okay, and I can even in the title, I can bring up these titles again. PLT title. I will add in that here start angle. I can add start angle equals to, let's make it 140. Pi got an expected start angle. Yes, you could see that it will just start it like that. And here PLT title will be what? Top 10 countries with maximum COVID. Top 10 countries with maximum COVID reporting. Okay, and X label will be axis equals to x label here. Will be like no need the x labels here, and everything is like good here. You see, it has just printed it out. Now we will just create another scatter plot and print out the relation between confirmed cases and deaths by country or region. Okay, I think that this is will be interesting. I will just create a variable, or first I will just type in the px scatter equals to, or inside of the scatter I will pass in the data frame itself, and x will be confirmed colon. Let's print out again the dataset to make sure that we have confirmed columns like this one. X is confirmed, y is deaths, y equals to deaths. Okay, and color will be let's make it like double edge origin. Let's just print it out. This might take a little bit like time, because this scatter plot is just analyzing all these numbers, summing it. You could see how will it print. If I just pick up like Europe, it will just only print out the Europe, or exclude the Europe, Africa, Eastern Europe, Western specific. You could see the only Americas and South Africa. This is the Southeast Asia. Only Southeast Asia is being printed out, and this is the remaining region. If I just add it, I will just click on it, and you could see it will just print it out without problem. Okay, and now I can even do what, adding another top number of death cases by country by adding the df group by again number of death cases by country. Okay, so in order to add it, I will just again copy this one, copy it, and group it by country, region, and deaths will be divided by 100 cases. Like deaths one, there is a specific column, I think here, df head. You could see deaths divided by 100 cases. This should be printed out, so I will just print them like this one, and country region is still the same, sum the same, and this will be removed here. Okay, and title is also no need yet. If I just print it out, I will just first print it out, run it, it will just, you could see, print out another countries like Yemen, United Kingdom, and everything. So I will just try to visualize it in a horizontal bar chart with the help of by typing the plt bar age. This is the horizontal like line. So the first one will be what, the index numbers, which is going to be passed here. So I will just type in the df9 variable here, and df9 will be the index first, like df9. If I just try to print out the f9 here, the f9, what will it print? Like the countries. Okay, and now in order to visualize it, I will first pick up what, the index number here, these countries, the country names, and the df9 itself, like the values. Okay, if I just run it, it will just print it out in a horizontal way. Okay, I can define the colors if I want, or make them a bit better. For example, colors will be added like here. Colors could be added just a minute. Colors, like 9 columns. If we have, for example, 1 2 3 4 5 6 7 8 9 10 colors should be added. So I don't have time to add in 10 columns. I will just print out the 4 here and add in the 4 columns here. So I will just add in the green, red, violet, gold, and gold. Okay, gold, and then run it, and here I will define those colors by adding the colors equals to color equals to colors, that variable. Okay, that should print it out. No, it hasn't printed. Invalid green, red. Why? This green, red is not supported because we don't have a comma here. Just put in the comma, run it again, and you could see, and you could just add in this line and even sort it if you want without problem. You can just add in the sort values, ascending, false, and that's it. I think this chart is pretty understandable for you. Okay, I think that's it for now for you. Thank you for watching this video. Subscribe to my channel. Have a good day. Bye.